Hello and welcome back, researchers. Today I am broadcasting from my office here at the university, and we're talking about correlational designs. We're continuing our study of quantitative research designs, and this is adapted from Chapter 11 in your textbook. So, a couple of definitions. In correlational research designs, investigators use the correlation statistical test to describe and measure the degree of association or relationship between two or more variables or sets of scores. The most common correlational statistic is the product moment correlation, and it's a statistics that is used when there's a linear relationship between uh, two two variables. Basically, you use correlational research to either explain or to predict. Um, you can examine the relationship between two or more variables or explain, or you can predict an outcome by looking at how the variables covary together, right? So you use one variable to predict the score on another variable. The um, the Pearson developed the correlation formula. So the Pearson moment correlation statistic is kind of the full name of the statistic that's most often used to describe correlation. Yule built on that work. For correlating multiple variables. Fisher, who we're going to learn about a lot, we'll talk about him a lot. He pioneered significance testing and the analysis of variance, which is a statistical test. Campbell and Stanley, I mentioned before, I think, wrote this really influential textbook. And then in the 70s and 80s, computers gave us the ability to statistically control variables and do multiple regression. So they gave us the ability to do more complicated and advanced statistics. My advisor tells a story about how in the 80s, when they used to do these more advanced statistics, it would take a really long time for the computers to process the math. This is all math and it's just repeated over and over again. And there were times when he would, set up his statistical program at 5 before leaving for the day and then come back to get his printout. Yeah, and back in the day when computers were much slower than they are now. Okay, so the steps in conducting a correlational study. First, we want to decide if it best addresses the research problem, and you're going to be receiving a flow chart to help you make that kind of decision. We want to identify individuals to study. We want to need to collect two or more measures for each individual in the study. We collect the data and we monitor potential threats. We analyze the data and decide how we're going to represent the results. Often we use graphs or a matrix, and we interpret the results. Okay, an explanatory study. Basically, you're correlating two or more variables. The data is collected at one point in time, and you're analyzing all the participants as a single group. You obtain at least two scores from each individual in the group, one for each variable. And then you report the correlation statistic or some other form of showing how the two variables relate to one another. And you base your interpretation on a statistical test to indicate whether a change in one variable is reflected in a change in the other. With a prediction design, you have a predictor variable, um, and that's the variable that's used to make the forecast about the outcome. And then you have the outcome variable, which is sometimes called the criterion variable, but it's more often called the outcome variable. So that's what I'll refer to it as. And that's the outcome that's being predicted. Prediction may be used in the title or the abstract. Predictive variables are usually measured at one point in time with the outcome variable measured at a later point in time, right? Because causality, we want the um, what happens first to precede what we expect to happen later, right? So the purpose there is to forecast future performance. Key characteristics of correlational designs are the associations between scores, and we're going to get more into each of these three things, the display of scores, and then um, multiple variable analysis is included under this umbrella of correlation designs. We're not going to talk about that very much because that is for a later course when you all are in the doctoral program. Okay. So, the direction of an association, either there's a positive correlation or a negative correlation. Um, and we use correlation, the term correlation in our, everyday speech. And basically, this is one of those terms that actually it's a similar meaning in statistical language, and that doesn't always happen. So, when two things are positively correlated, that means they um, relate. When one goes up, the other one also tends to go up, right? So, for example, let's see. Um, the more the more I eat, we'll do this. The more I eat, the more I'm likely to weigh, right? So as the calories I eat goes up, so does my weight, right? That's a positive correlation. The more I exercise, the less I'm likely to weigh. Um, and so there's a negative correlation. As I exercise more, my weight goes down. Okay, so there's a simple um, kind of explanation of positive and negative correlations. Now, if there is no pattern, there's and no linear association, we say that the two variables do not correlate. Okay, and this is what. Okay, so there's another possibility. So there could be a positive linear relationship, a negative linear relationship, right? So the positive is calories and weight. The negative is exercise and weight. Or there could be a curvilinear relationship. That's like a U-shaped relationship between two things. One example for a curvilinear relationship is anxiety, okay, and achievement, right? So if I have very low anxiety or low motivation related anxiety, if I don't care about how well I do in a class, I'm likely to get a low grade, right? If I care somewhat, and I'm a little bit nervous about it, then I'm going to study hard and I'm likely to get a high grade. If I am really anxious, I think there's no way I can do this. Oh my goodness, this is going to be so hard. I might psych myself out and get a low grade. Okay, so that's an example of a curvilinear relationship. So, associations between scores. What's the form of the association? So Pearson, his product moment correlation statistic is usually represented as a lowercase r, and it's called a correlation coefficient. And we use that for continuous data when we have two continuous variables. Spearman's rho, that's when you have nonlinear ordinal, right, categorical ordinal data. And you know what all these things are now, right, from our previous lesson. A point biserial correlation is used to correlate continuous data with dichotomous or binomial variable. And the phi coefficient used to determine the degree of association when both variable measures are dichotomous or binomial. So here's a visual representation of positive, negative, and no correlation. So let's say on the bottom we have an, the number of calories that um, um, Dr. Campoli is habitually eating. And along, that's the x-axis. Along the y-axis, we have Dr. Campoli's weight, right? And so we see how my weight might vary depending on the number of calories I'm habitually eating. As as one is higher, so is the other. And then the negative example was exercise, right? The more exercise I do, that's the x-axis, and then there might be, my weight might be less, right? So if I'm, you know, checking each, I don't know, year, 6 months, and taking data on how much I'm habitually exercising and how much I weigh, we might see a pattern like this. Now, if there's no correlation, you just kind of see this kind of scatter shot when you're looking at a scatter plot, right? So the dots, they don't make a line, they don't form a pattern. And here's that curvilinear relationship I talked about, right? So here's where you don't care about the grade, right? You care about the grade, you're a little bit nervous, so you study really hard. Here's where you're really anxious and you psych yourself out, right? And so you might end up with a low grade. Um, so that's an example of a curvilinear relationship. The Pearson product moment correlation statistic only works if you have a linear relationship. So one of the things we'll talk about is how it's important to plot out your data and see what kind of relationship you have before you use a particular statistic. So R, that correlation coefficient, um, can range from -1 to +1, with 0 indicating no correlation. And there's something called the coefficient of determination, which um, um, describes the proportion of variance in one variable that can be explained by the other. And if you have no idea what I just said, don't worry. We're going to about these the parts of these that are important for you to be able to do your studies. We'll get into more next week and the week after. Okay, so don't worry if you're like, what? Okay, so as you're reading research, you might come across where the authors have reported the correlation coefficients, right? They might say that R equals zero point 0.2 or R equals 0.35 or R equals 0.66. And this kind of gives you a range of what um, in what is considered a slight relationship or weak relationship all the way through to a strong relationship. In education research, because learning is so complex, and there are so many factors involved in learning, a rule of thumb, we're not expecting to get super high correlations in the same way that we might in other fields. So yeah, around a point 0.1 is a weak correlation. That's pretty close to 0. Around a point 0.3 is a moderately strong correlation. And if you're around zero point 0.5 in education, that's considered great. That's considered a strong correlation. And this is a rule of thumb. The best way to know what's a good correlation coefficient is to look at existing studies and see what the authors are reporting. But but just as a rule of thumb, in education, zero point 0.5 is considered a strong relationship between two variables. Okay, we can display our scores in scatter plots like the plots we've looked at. Um, and you can tell the direction, the form of the association, and the degree of the relationship with a scatter plot. So here's another example of a scatter plot. Hours of internet use, is that correlated with depression? And looking at the scatter plot, it does look like there is a linear relationship where um, spending more time on the internet is associated with feeling more depressed. Okay, you see that? Who's this with a 5? Below a 5 and a 17. Yeah. So Maxine only is on the internet twice for 2 hours a week and has the lowest depression score of all of the people who were studied in this study. Um, Whereas, who's this? Above 15. Okay. Jamal spends about 18 hours on the internet and has the highest depression score at 48. Okay. So you see how that goes? Usually there's just the dots in a scatter plot. There's not the circle and the lines. But that helps us see the circle and the lines helps us see the linear relationship there. So is that a positive or a negative correlation? That's positive because as one goes up, so the other one tends to be higher as well. Now, another way to show the scores when you're doing a correlational study is a correlation matrix. And this shows all the correlation coefficients for all the variables in a study. The variables are listed on both the horizontal row and the vertical column. And asterisks indicate whether the correlation is statistically significant, which we'll talk more about what that means soon. And so you might see in a journal article something like this, okay, where you have the correlation coefficients. It indicates whether they are negative or not. This should be 0.33 because it ranges from -1 to +1, right? And you have this like triangle shape because one is school satisfaction. We see school satisfaction has a moderately strong association with extracurricular activities. One represents school satisfaction. So if I just read this down, friendship has a also a moderately strong association with school satisfaction. Self-esteem has a negative association, kind of a weak negative association. Pride in the school is very close to zero. That's almost no association, very weak. But self-awareness has a positive association with school satisfaction, okay, because one represents school satisfaction. So that's how I read down a correlation matrix. And we'll get practice at that when you all are doing them yourself. Okay, linear regression is used to predict, right? So there's I think there's an internet personality or two who is famous for being able to predict. I can't remember if it's stuff in sports or politics or something like that. Anyway, what they use to make predictions, whether it's in sports or politics or financial predictions, is a process called regression. And if you remember from high school, I know for many of us it was quite a while ago, but the equation for a line, I remember learning y equals mx plus b, right? So it was that y equals the slope times the x value plus some intercept, right? And um, it's the same thing for linear regression. Y is the predicted score, x is the predictor variable, B is the regression coefficient, which is the slope of the line, and A is the intercept or the constant when x what y is when x is 0. And we estimate y using the values of the outcome variable. Um, and we're going to touch on this, but yeah, we'll touch on this more later on. You'll see how to do this. And so again, we have a scatter plot, right? That's the dots. Okay. And then the line is the best fitting line to represent the dots. Okay. And basically, it's where the line is our regression line or our line that predicts what the depression score will be given the hours of internet use. Okay. So regression is for prediction generally. Now, there are some potential ethical issues in conducting correlational research. One is you have to include the appropriate controls, or else it may look like there's a strong correlation when actually you're not quite measuring what you think you're measuring. You need a sufficient sample size, and you also need to meet the assumptions of the statistics, specifically that there's a linear relationship. One ethical issue is people say cause and effect when it's actually patterns of relationships. They haven't quite established causality. Another problem is sometimes folks don't report effect sizes or significance testing, and those are just ways to strengthen your argument using statistics. And it becomes a real problem for any study when contradictory findings are left out. Yeah, selective reporting there. And also, one of the things that we want to be able to do is replicate another person's research. And that way, we just strengthen the knowledge base if studies can be replicated. And so, in order to do that, data has to be shared with others. Okay. So those are just some ethical issues that may but come up, but hopefully won't. All right, so that's the end of our examination of correlational research. See you next time.